In 1962, the United States detonated a nuclear bomb in space, not above a city, not over a battlefield, but high above the Pacific Ocean, nearly 400 kilometers above Earth. The weapon was roughly 1.4 megatons, almost 100 times more powerful than the bomb dropped on Hiroshima. For a few seconds, the sky itself became part of the experiment. People in Hawaii saw the night turn bright. Artificial auroras spread across the Pacific. Streetlights failed, alarms went off, radio links were disrupted, and then something even stranger happened. The explosion did not end when the flash disappeared. It left something behind. An invisible belt of radiation wrapped around Earth, a man-made storm trapped in the planet's magnetic field. And over the following months, satellites began to fail. This was Starfish Prime, the nuclear test that did not just light up the sky, it proved the sky could be broken. In the early 1960s, the Cold War was moving upward. The United States and the Soviet Union were no longer thinking only about tanks, bombers, submarines, and missile silos. They were thinking about space. Satellites were becoming the eyes and ears of the superpowers. Missiles were getting faster. Radar networks were expanding. Communications were moving through the atmosphere and into orbit. But there was one terrifying question no one fully understood. What happens if a nuclear weapon explodes above the atmosphere? Would the blast disappear harmlessly into space? Would the atmosphere absorb it? Would satellites survive? Would communications fail? Could one bomb blind an enemy before a nuclear war even began? The answer was not in any textbook, so the United States decided to test it. The program was called Operation Fishbowl. It was part of a larger nuclear testing series, but Fishbowl had a very specific purpose: detonate nuclear weapons at high altitude and measure what happened. The idea sounded almost controlled. Launch a missile from a remote Pacific atoll. Send the warhead hundreds of kilometers above Earth. Detonate it far from cities. Watch the instruments. Collect the data. On paper, it was an experiment, but in reality, it was an attempt to weaponize the edge of space. The first attempt did not go smoothly. Before Starfish Prime, there was an earlier Starfish launch. That missile failed. The rocket had to be destroyed after launch, scattering radioactive debris around Johnston Atoll. It was an early warning. Even before the main test succeeded, the experiment had already shown how dangerous this new frontier could be. But the program continued, because the question was too important. If nuclear weapons could be used above the atmosphere, they might become a new kind of strategic weapon. Not a city killer, a system killer. A weapon designed to attack communications, radar, satellites, and electronics. So on a July night in 1962, the United States tried again. A Thor missile lifted off from Johnston Atoll, a tiny island in the Pacific Ocean. At the top of the rocket was a W-49 thermonuclear warhead. Its destination was not a target on Earth. Its target was the sky. The missile climbed higher and higher, leaving the dense atmosphere behind. Then, around 400 kilometers above the Pacific, the warhead detonated. For a moment, a miniature sun appeared above Earth. But this was not an ordinary nuclear explosion. At that altitude, there was almost no air to carry a shockwave. No mushroom cloud rising from the ground, no city flattened beneath it. Instead, the weapon poured energy into near space. X-rays, gamma rays, charged particles, electromagnetic energy. The bomb had exploded where Earth's atmosphere begins to thin into space, and that changed everything. From the ground, the effect was surreal. Across the Pacific, observers saw artificial auroras spread across the sky. Bands of red, green, violet, and white appeared in the night. The glow was not natural. It was the atmosphere reacting to a nuclear weapon. Charged particles from the explosion collided with gases high above Earth. Oxygen and nitrogen lit up. The sky shimmered with colors that looked almost beautiful. And that was the disturbing part. For many people watching from Hawaii, it felt like a spectacle. Some gathered outside to see it. Some treated it almost like a public event, a strange Cold War light show in the heavens. But the scientists were not watching for beauty. They were watching the instruments. And the instruments were telling them something was wrong. The effects were stronger than expected. The glow was brighter than expected. The reach was wider than expected. The bomb had not behaved like a contained experiment. It had touched a huge region of the upper atmosphere, and then the invisible effects began to arrive. Nearly 1,500 kilometers away, in Hawaii, the pulse hit. Not as fire, not as wind, not as radiation that people could see, but as electromagnetic energy. Streetlights in Honolulu failed. Burglar alarms were triggered. A microwave communication link was disrupted. The blast had happened high above the Pacific, far from the Hawaiian Islands, yet its electromagnetic pulse reached down into ordinary human infrastructure. This was the moment Starfish Prime changed from a scientific test into a strategic warning. Because if a nuclear weapon in space could affect electronics more than 1,000 kilometers away, then the battlefield was no longer only the place beneath the explosion. The battlefield could be an entire region, maybe an entire continent, maybe every system connected by wires, antennas, radar, or satellites. The United States had just demonstrated something frightening. A nuclear weapon did not need to hit the ground to damage a modern society. It could detonate above it and let physics do the rest. The reason was the electromagnetic pulse, EMP. A nuclear explosion releases gamma radiation. At high altitude, those gamma rays interact with molecules in the upper atmosphere. That interaction knocks electrons loose. Those electrons are then forced to move by Earth's magnetic field. The result is a sudden, powerful electromagnetic pulse, a wave of energy that can induce current in electrical systems. In simple terms, it can make electronics behave as if they have been struck by an invisible surge. In 1962, the world was still mostly analog. No smartphones, no GPS in every car, no global internet, no cloud data centers, no modern digital banking infrastructure. And still, Starfish Prime caused failures. That is what makes the test so chilling today. If a high-altitude nuclear burst could affect Hawaii in 1962, what would a similar event threaten now? Satellites, power grids, undersea cable landing stations, military communications, emergency broadcasts, banking systems, navigation networks, data centers, air traffic control. Modern civilization is not just connected, it is electrically synchronized. And Starfish Prime revealed a weapon that attacks synchronization itself. But the EMP was only the first surprise. The second surprise was waiting in orbit. When the warhead detonated, it threw high-energy electrons into Earth's magnetic field. The planet's magnetic field normally protects Earth from charged particles coming from space. It guides them, traps them, moves them along invisible magnetic lines. But Starfish Prime injected a massive artificial population of particles into that system. The explosion created a temporary man-made radiation belt, an invisible ring of charged particles around Earth. This was not just a flash, it was a lingering environment. The bomb had changed the conditions of near-Earth space. At first that may sound abstract, but in 1962 humanity had just entered the space age. Satellites were still rare, fragile, experimental, expensive. And suddenly, Earth orbit had been contaminated by radiation from a nuclear weapon. The damage did not happen all at once. That made it even more disturbing. Satellites did not simply explode in the sky, they began to degrade. Electronics failed, solar cells were damaged, signals weakened, systems behaved unpredictably. The sky had become hostile. One of the most famous victims was Telstar 1. Telstar was not just another satellite. It was a symbol of the future. Launched in July 1962, just after Starfish Prime, Telstar helped make the first live transatlantic television signals possible. For the first time, images could be relayed across the ocean through space. It was a glimpse of the connected world we live in now. But Telstar flew into an orbital environment that had just been poisoned by nuclear testing. It worked, then it failed, then it recovered, then it failed again. Radiation damaged its electronics over time. That slow death was more frightening than an instant explosion, because it proved the radiation belt was not just a momentary side effect. It was a trap. Ariel 1, the first British satellite, was also damaged. Other satellites suffered as well. Depending on how the losses are counted, Starfish Prime and related high-altitude testing damaged or degraded roughly a third of the satellites then in low Earth orbit. A third. Today, that number would be unthinkable. In 1962, there were only a few dozen satellites in space. Now there are thousands. Communications satellites, weather satellites, military satellites, navigation satellites, Earth observation satellites, commercial constellations. The modern world has built an invisible nervous system around the planet. Starfish Prime was the moment humanity learned that this nervous system could be attacked. The most unsettling part of the test is how wrong the expectations were. Scientists and military planners knew there would be effects. That was the point of the experiment. But the scale surprised them. The artificial aurora was brighter than expected. The EMP effects reached farther than expected. The radiation belt lasted longer than expected. The satellite damage was more serious than expected. The models were incomplete. The sky was not empty. It was not a clean vacuum where a weapon could be tested without consequences. It was a complex electrical environment. A system of charged particles, magnetic fields, radiation belts, communication signals, and fragile machines. Starfish Prime did not just produce data, it exposed ignorance. The United States had detonated a thermonuclear weapon above Earth and discovered that near space was more connected to the ground than anyone wanted to admit. A bomb in space could affect a city below. A flash above the atmosphere could poison an orbit. A military experiment could damage civilian technology. A single detonation could create consequences that lasted long after the fireball disappeared. This is why Starfish Prime matters. Not because it was the largest explosion, not because it destroyed a city, but because it revealed a new kind of vulnerability. A world dependent on electronics can be threatened without ever being directly hit. By 1963, the lesson had become impossible to ignore. The United States, the Soviet Union, and the United Kingdom signed the Partial Test Ban Treaty. The treaty banned nuclear tests in the atmosphere, underwater, and in outer space. It did not end the nuclear arms race. It did not eliminate nuclear weapons, but it did close one of the most dangerous chapters of testing. No more nuclear bombs in the sky, at least not as tests. Starfish Prime had shown that high-altitude nuclear explosions were not clean experiments. They were planetary events. They could affect the atmosphere. They could affect communications. They could affect satellites. They could create radiation belts that outlived the explosion itself. And as the space age accelerated, the risk only became more obvious. A nuclear weapon in space was not just a weapon against a target. It was a weapon against infrastructure, against trust, against the systems that allow modern life to function invisibly in the background. Today, Starfish Prime feels more relevant than ever. In 1962, a satellite was a rare machine. Today, satellites guide aircraft, synchronize financial transactions, track storms, support military operations, connect remote regions, and power the timing systems behind digital networks. We do not see them most of the time, but we live underneath them. Every GPS signal, every weather forecast, every satellite phone call, every military navigation system, every emergency coordination network, all of it depends on the assumption that orbit remains usable. Starfish Prime challenged that assumption. It showed that space is not separate from Earth. It is part of Earth's infrastructure. And if that infrastructure is damaged, the consequences do not stay in the sky. They come back down, into power systems, into communications, into transport, into banking, into war planning, into ordinary life. That is the hidden terror of Starfish Prime. The explosion happened above the atmosphere, but the lesson landed on Earth. There is also a strange irony at the center of the story. For people watching in Hawaii, the test looked beautiful. A glowing sky, artificial auroras, a spectacle of color over the Pacific. But beauty was only the visible edge of the event. Behind it was a pulse strong enough to disrupt electronics, a radiation belt strong enough to damage satellites, a scientific shock strong enough to rewrite military thinking. The sky looked alive because it had been struck by a nuclear weapon, and for a few seconds the Cold War became visible in the heavens. That is why the story still feels unreal. Not because it is science fiction, because it actually happened. A government launched a nuclear warhead into near space, detonated it above the planet, watched the sky change color, watched electronics fail hundreds of miles away, watched satellites die afterward, then realized the experiment had reached far beyond the test zone. Starfish Prime was not just a nuclear test, it was a warning flare from the future. And that warning is still with us. The modern world is more advanced than the world of 1962, but it is also more fragile in ways the people of 1962 could barely imagine. We have hardened some systems. We understand EMP better. Satellites are designed with more radiation protection. Military networks plan for hostile space environments. But our dependence has grown even faster. More satellites, more electronics, more automation, more cloud infrastructure, more systems that assume the invisible signals above us will always be there. Starfish Prime reminds us that the sky is not just empty space. It is a battlefield, a shield, a highway, a sensor network, a fragile layer of civilization. And in 1962, one nuclear bomb proved how quickly that layer could be disturbed. So when we look back at Starfish Prime, the real question is not only, why did they do it? The deeper question is, what would happen if someone did it again? If you want more stories from the classified edge of history, real operations, real experiments, and real consequences, subscribe to Redacted Briefing. Because the most disturbing part of history is not always what was hidden. Sometimes it is what was done in the open sky. Starfish Prime lasted only seconds, but the radiation remained. The satellites failed, the treaty followed, and the warning never disappeared. A single bomb had turned the Pacific night into a glowing curtain. It had reached into Hawaii without touching it. It had wrapped Earth in an artificial radiation belt, and it had shown the world that the next battlefield might not be on land, at sea, or in the air. It might be above us. Silent, invisible, already connected to everything. Starfish Prime did not just break the sky. It showed that if the sky breaks, so do we.